This video will show you one more use for the trig identities that you've already learned. So far we've used them to evaluate trig functions for specific values. Now you're going to see how many different trig expressions are equivalent to one another, and you need a good working knowledge of the identities in order to follow this lesson and to do the work. So first thing I want to say, either put the identities in front of you, they're in your textbook, they're in your notes, or if they're really already in your brain, then that's fine too, but it might be useful to actually have them in front of you because I'll be using them for the rest of this lesson. Suppose you're given the expression cosecant theta tangent theta, and your instructions are to rewrite it or simplify it. Well, the first thing I'm going to do, and this is always a good strategy, oops, got to plug in my tablet. If you don't know what else to do, it's always a good idea to rewrite things in terms of sines and cosines. So let's see, let's turn the pen back on. So cosecant is 1 over the sine, and tangent is the sine, let's get that out of there, is the sine over the cosine. So again, cosecant is 1 over sine, tangent is sine over cosine, and then you know from algebra when you multiply two fractions you can cross cancel, and I get 1 over cosine theta, and then the best way to write that is secant theta. So that would be a basic example of how you can use trig identities to rewrite trig expressions in a more convenient or simpler form. This next one, the first thing I'm going to notice is that both of the terms, the first one as well as the second one, involve the sine of x. So I'm going to use some algebra here. I'm going to factor out sine x, which leaves me with 1 minus cosine squared x. And the next step, I'm actually going to write this off to the side. Since sine squared x plus cosine squared x is always equal to 1, that implies that 1 minus cosine squared x should be equal to sine squared x. Alright, that's a little messy, but so the sine of x I'm going to rewrite as sine x, and the 1 minus cosine squared is equal to sine squared x. And then sine of x times sine squared of x is sine cubed x. Okay, again, you had to have a working knowledge of the Pythagorean identity, sine squared plus cosine squared equals 1, so that you could substitute the 1 minus cosine squared. You need to know that that's equal to sine squared. Again, this is kind of messy. Let me rewrite that. So sine squared x is 1 minus cosine squared x. Alright, this one involves adding two fractions. So in order to add them, we need a common denominator, which would be simply the product 1 plus cosine theta times sine theta. Can't do any better than just multiply the two denominators together. So that means that this denominator was multiplied by sine of theta, so the numerator, when you multiply it by sine of theta, it becomes sine squared theta. And then the second fraction, you have to multiply the numerator and denominator by 1 plus cosine theta, and so you get 1 plus cosine theta times cosine theta. Alright, and let's just clean this up a little. So we have sine squared theta over 1 plus cosine theta sine theta, plus, now I'm going to distribute this cosine and get cosine theta plus cosine squared theta all over, and again the denominator is that common denominator. So the cosine times 1 was cosine, and the cosine times cosine is cosine squared. Now I can combine that into one fraction, sine squared theta plus cosine theta plus cosine squared theta, and the denominator is still 1 plus cosine theta times sine theta. And then note that the sine squared and cosine squared always add up to 1, so I get 1 plus cosine theta over 1 plus cosine theta sine theta. And then it might be useful to put this in parentheses so you can see clearly that factor cancels out, leaving me with 1 over sine theta, or the simplest way of expressing that is cosecant theta. Alright, a lot of steps on that one. Got to know your algebra, got to know how to add fractions, find common denominators. It's all in there. Okay, one more. I think, maybe two more. So, same strategy I used on the first one. I'm going to rewrite everything in terms of sines and cosines. So, cotangent is cosine over sine, and then, let's see, and then that's just cosine over 1, I guess. I don't know where this one's going. So I get sine t plus cosine squared t over sine t. And I could write that as sine t over 1. Okay, I know where I'm going. So then I have, if I multiply the numerator and denominator of the first one by sine t, I get sine squared t over sine t plus cosine squared t over sine t. Now that the denominators match, it's just sine squared t plus cosine squared t over sine of t. And then sine squared plus cosine squared is 1. And 1 over sine t is cosecant t. For your homework, here's 4 different expressions that I want you to simplify. And each answer, when you're all done, should involve only one trig function. I know that this is challenging, so my expectation next time when you come to class, even if you haven't solved them all completely, I do expect to see that you've tried something on each one. And remember, a lot of times, all you need to do is rewrite things in terms of sines and cosines, and that might be enough. Alright, make sure you have something ready for class next time.